So we'll be dealing with classes in this session. A class is just basically like a template, or you can call it a blueprint, which has a block of code with some initial contents and some member functions or variables that you can use. So similar to functions or methods, but class gives you the object-oriented features, which allow things such as encapsulation, inheritance. So basically writing code in a more modular form. So let's say if you've got a car, let's say Toyota RAV4, you can have the basic blueprint of RAV4 in terms of the lights, placements, the year it was made, the chassis and everything. But you can have various objects of that blueprint. So you can have a RAV4 that was made in 2024 or one that was made in 2023 with some slight differences, or you can just follow that blueprint to create so many versions of it. So the key thing is that a class is just basically a blueprint from which you can create several objects or instances of the class, each of them obtaining some of the features that are laid in the basic template. So let's see how this is done in Python. So I'll get rid of the screen now. And in Python, the keyword is class. Let's call a class maybe ball. And you need the colon operator. And again, indentation means that everything in there belongs to the class. So everything that's indented belongs to this particular class. So one other keyword similar to constructors that you find in C++ is we start with def and two underscores, the init, another two underscores, and then you put the self. Self here points to every instance of this class that is created. So pointing to the instance of that class. So let's say later if we create a basketball, then this will be self will be pointing to that. So we say that instance, we want to go in there and we want to assess that instance and maybe set the diameter of the ball to none at the moment. And again, we can do the same and we just set the color to none. We want to move one level up of the indentation and we can call something such as bounce method. And we set it to self. And in there we can print and we can print something like bouncing. And we want to set another method or function and we call it roll, to roll the ball. You point to itself and we'll print. So it's just basically pointing to this particular instance of the ball. So print rolling. So if you think of a class as your as a new data type that you have created, so you can create, it's just the same way you have integer data type, you can use it to create a variable and other things. So we just need to create an instance of this class, and that instance will be the object of the class that we are creating for it. So what we're saying is that we've got the basic blueprint where we can have different types of balls, and each ball will have a diameter and a color or initialized to none when they are created, and the ball has some features of bouncing and then maybe rolling as well. So let's create an instance of this ball. Let's call it maybe a cricket ball. I'll use capital. Let's stick to that convention. Cricket ball, and I'll assign it to of type ball, which means that we're just creating cricket ball, which will have these features. And then I will also create tennis ball, and it's also of type ball. So what we want to do is when for the tennis ball, cricket ball, we want to access these variables and then we want to change them. So we use the member access operator, which is just simply a full stop or the dot operator. So this means that we go to tennis ball. Within tennis ball, we can have access to diameter. So inside tennis ball, we pick the diameter and we set the diameter to 7.8. Just random number. And the same, we want to take the cricket ball and we want to set the color to blue or yellow, right? We can do the same for the tennis ball as well. So tennis ball, we've got diameter. So dot member access operator allows us to access that. We can send it to maybe something 8. And then the tennis balls color to maybe blue. Not realistic, but let's work with that. Right. So at the moment, all we've done is just set these things. We've not really printed anything, but we can also access these member functions. So let's take the tennis ball. And we want to maybe bounce the tennis ball. And when we bounce it, it should say bouncing. So tennis ball, and then we can go for bounce. And because it's a function, it will have this brackets open and closing, which is pointing to the self. So you just inside the tennis ball, it will find that and it should print bouncing. So let's do print, and we'll say bouncing tennis ball, and we just bounce that on the second line. Let's run that and see what happens. So we just say bouncing tennis ball, and we can just basically try to do a few things as well. So we've set these parameters. We've managed to maybe bounce it. We can try to roll it as well. So let's see whether changing the diameter for the cricket ball to 7.8, the color to yellow, these changes that we made here, let's see whether they did actually make effect, right? So let's go into line 18 where we would print, and in there we want to print tennis ball dot diameter. Print that out and see. So let's say if we run it, it printed 8, which is what we said there. Then let's do the same. Tennis ball dot color. And we do the same for cricket ball. So we run it and see, and we realize that the colors are the right color. The tennis ball is blue, cricket ball is yellow, and then the diameters are set there as well. So probably we could improve this bit. Let's say diameter of tennis ball is we've got that. And we can have, let's run it and see, comma. Can have that there. Yeah, so diameter of tennis ball is 8. We can have, again, diameter of cricket ball is, comma there. And then we can have the color of tennis ball. So change this to cricket. Comma, then change this to color. And again, I'll do the same. So I will have the color of the cricket ball is cricket ball. Have the color of cricket ball. So just run it and it's neatly done on there. So basically, all we've done in this session is just introduce the idea of classes, the fact that it's a blueprint or template that we can use to create object. So in this case, we have diameter, color, and then 2 functions in there. So each of these objects we created of ball have those features that we laid out here. And so each tennis ball will have its own diameter, its own color, and then also bouncing and rolling features. Then again, we mentioned that this init is similar to a constructor, meaning when you create each of these instances, like tennis ball, cricket ball, straight away, there the diameter will be associated with none. So let's try to print similar here to see what happens. Let's just make a change. As soon as we created the tennis cricket ball, change this to cricket ball. And change this to cricket ball as well. Right at the bottom, so line 11, and I expect there to be none. So as you can see, as soon as it was created, by default, it was changed to none. So let's change this to 100 and see what happens. And 1000, and then maybe the color to something white. So realize that let's do the same for color. We've got the 1000 being the default that is associated with the cricket ball when it's created. Let me just say tennis ball, and then we print the color of that. So tennis ball, and then print the color. Not diameter, color. So run it, and you see that we've got by default the color, the diameter was 1000, color was white, and then later we could update it. So once we create a function, say pointing to itself, it means that we can just use instance. Self simply means instance of the class that's created, like cricket ball or tennis ball, basketball, whatever we create out of it. Hope you found this session useful. All the best.